Okay, moving on to chapter 9. We should have a quiz. Let's do a quiz tomorrow. Wait, tomorrow. Today's Thursday. Um, yeah, we should do a quiz next week on just the chapter 8 stuff on the Monday. It'll be a short quiz, just probably like 1 or 2 questions. Can you graph it and can you solve it with one of those methods? Anyway, chapter 9. So now this is our last chapter in the entire textbook. Congratulations. A little cheers, pat on your back. And this one's all about inequalities, which I don't think they're hard, but I think they're very different. I think that's what catches people off guard. They are a fair bit different from everything else we've been doing. You have to look at things a little bit differently. So as long as you practice it, I think you're going to do just fine. If you don't practice enough, then you might get caught off guard. Kind of like the absolute value unit. I would say very similar to that. Not hard, but different. Okay. This one actually starts out with an investigation. So the first 2 pages, I want you to pause the video, turn to page 464, or if you've already done this, please do it and fill in the first like 11 or 8, I guess we have parts to this, and give that a try. If you need help with that stuff, come see me after. I'm going to do just this part of the lesson. Okay. Linear inequalities in 2 variables may be one of the following 4 terms. And we're going to look at these in standard form, which is with all the variables on the left and kind of numbers on the right. So you could see it as ax plus by. Actually, let's do that for every single line. And then over here, C, 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 C. So A, B, and C are just numbers. They're real numbers. They could be integers or decimals or whatever. And inequalities can be of 4 different forms. The left could be less than or equal to, which we do like that. So I still think every single time, alligator likes to eat the bigger number. So that means our constant C is bigger than whatever the variables are. It could be strictly less than, which is almost the same, except it's never allowed to equal C. It could be greater than and equal to, or it could be greater than. And we've been looking at these since middle school, and you saw them again in grade 9. So hopefully you're fairly comfortable with these symbols and kind of generally how they work. An inequality in 2 variables, x and y, describes a region on a Cartesian plane. So we're going to be looking at a whole area, which is possible solutions. So there's not just a possible solution, there's not an entire line of possible solutions, now there's an entire area of possible solutions. And we kind of see that down here. Ax plus by equals c is going to be this dotted line here. So the whole top part is going to be where it's greater than. This is the boundary line where it's equal, and the whole bottom is the less than area. So it's an entire region of possible solutions. So solution regions, the solution set is all the points on the plane which are true. Now there's many, many, many of them, of course, because anything that's bigger in this case is going to make it true. Anything that's smaller in this case is going to make it true. Lots of solutions. So we actually care less about specific solutions in the solution region. What we care more about is the boundary. So we want to set boundaries for these things. The boundary is the line or the curve that separates the Cartesian plane into 2 regions. This line may or may not be part of the solution. That depends on whether the equal sign is in there. In these ones it is part of the solution, the boundary line, and in these ones it is not. In 2 and 4 it is not. And that decides whether you draw it with a solid line or a dotted line. And that's what it says here. If it's solid, that means it's included. If it's dotted, it's not included. Fairly straightforward. For example, and this is kind of an example of it, if we have ax plus by equals the number c, we'll pretend that creates a line like this dotted line. We don't know what that line would look like, but let's pretend it's the dotted line. And that would make everything above it the solution to ax plus by is greater than that number c, and everything beneath it is less than. Okay, let's try it. We just have 4 examples. So graph 2x plus 3y is less than or equal to 6. So first thing we want to do, and then B, find out if a certain point is in the solution. First thing we want to do is write this as a line and graph that line. Well, I'm going to need a ruler. I got a makeshift ruler here. So let's pretend 2x plus 3y is equal to 6. Let's find where the boundary line is. So we subtract 2x. We divide by 3. And dividing by 3 means dividing every term by 3. Either the whole thing gets divided by 3, or it breaks down to every single term, which is the better way to do it, if you want to do it quick. So then graph that. It starts at plus 2. And then from there it moves 2 rise over run, 2 down, 3 right. So 1, 2, 1, 2, 3. And really you only need the 2 points. And once we connect the dots, we get the entire line. Just making sure I do it accurately. Should look something like this. Now I already kind of made a mistake. I went right ahead and made the line solid, but I happen to have made a correct mistake in this case. I failed successfully. This was an equal sign, so it is actually a solid line because everything on the line is actually included in our region. Now we want to know when it's less than that number. So that's everything beneath that. I always like to think, the easy way to think about this is whichever side the y is on, that's going to be where all the rest of your solutions are. So y has to be less than the number that we found or the line that we found. So it's actually this region. Everything down there is a possible solution, including our line itself. So now let's just check the point. It's really easy in B. Is negative 2, 4 in that shaded region? So negative 1, 2, positive 1, 2, 3, 4. So that's this point right here. No, it is not a solution. Another way you can do this is by subbing it in. So let's actually check that. So negative 2 is the x value. So 2 times negative 2 plus 3 times our y value, which is 4. And we want to check if it's less than or equal to 6. Don't set it less than or equal to, because that's, again, kind of not really allowed. This is our left side. This is our right side. For checks, we have to split them up. But I do put my symbol there to remember that it's not equals we're checking. We're checking to see if it's less than or equal to. So negative 4 plus 12 is equal to 8. Each side is equal to itself. So is 8 less than or equal to 6? No. Does not work. Okay, so we can do it graphically and we can do it algebraically. Let's do it one more time. So very similar, almost the same steps. We want to graph the boundary line, but this time with a dotted line. Let's try not to forget. So negative 5y is equal to negative 10x plus 0, which doesn't matter. So y is equal to 2x. Well, that's a nice easy line to draw. That goes through the origin, and then it's got rise of 2 over 1, rise of 2 over 1, rise of 2 over 1. Now remember, dotted line this time. It really does matter. I will dock you points if you don't do a dotted line. So, dotted boundary line, and are we going above it or below it? Actually, my old rule doesn't really work for this one. So we actually want to check here. We probably want to solve this with the actual equation. So this was, yeah, sorry, this rule actually, I'm going to have to revise. And I'll go back to that one after. So this one, if we were solving this thing, we would say 10x minus 5y is greater than 0. We would subtract 10x, which is allowed. Now, do you remember the big rule in grade 9? I want to divide by -5 here. So I divide by -5, that becomes that, that becomes that, and then the special rule is whenever you're multiplying or dividing by a negative number, this actually flips. Okay, so we actually have to go off of this. So it's probably better to do it this way right from the get-go, rather than finding the actual boundary line. If you do it like this, then you can create the boundary line and know what the region's going to be. So I should have done it this way from the start. But anyway, this means all of our y values, which are beneath this line. So it's actually down here. That's actually the region we're looking for. Now let's go back up here and try it with this one. Let's pretend this was a less than or equal sign. What did I do? I subtracted 2x. Well, that doesn't change anything. That could be a less than or equal sign. And then I divided by 3. And that's positive 3, so that actually doesn't change anything either. So that's still less than or equal to 2. So in this case, it still was less than that line, so we got this one correct as well. But we should do it that way. Sorry, I forgot that the first time. Okay. If you're doing this, it might be prudent, if you're a bit rusty, you might want to just check a point. So this kind of suggests that 0, -2 works. Or even 0, -1, but you could sub in any kind of point, and let's just see if it's true. So left side is 10 times 0, so -5 times -2, and the other side is 0, and we're checking to see if it's greater than. And that becomes positive 10, which is indeed greater than. So the region is beneath that line. If you found the line correctly, a single point should be all that you need to tell which side is actually your correct region. All you had to do was find that line, and then if you check this sign, then you know it's the bottom. If you check 0, positive 2, and that was true, then you would know it's the top. Okay, last 2 questions. And then you'll have lots of time for homework, hopefully, depending on how long that investigation took you. Write an inequality to represent the following graph. Oh, this isn't going to be too bad. Why don't we write the equation for the line and then change it to an inequality after. So this line goes through the point 1. So we know it's going to be a +1. We know it's a y. And what's the slope? 1 to the right, 2 up. So 2x plus 1. Just grade 9 math, finding equations for lines. We should be able to do that, not too bad. That's the y equals 2x plus 1. Now we're looking for everything above the line, so all of our y values, that's all of our actual solutions, needs to be bigger than the line. Can it equal the line? Well, in this case, no. So it's just greater than. That's it. This could be a multiple choice question, and it should take you less than 30 seconds. Hopefully, we can do that really quick. Last question. Write an inequality. Write and solve an inequality. So these ones become a little bit harder. I always find these kind of confusing, because I usually like to think in terms of equations instead of inequalities, but let's try and figure it out. So, suppose that you're constructing a tabletop using aluminum and glass. The most you can spend, that means we're going to be looking to spend less than the maximum amount. The most you can spend on material is $50. Glass costs $60 per meter squared, and aluminum costs $1.75 per feet. You can choose the dimensions of the table and the amount of material used. Find all possible combinations of material sufficient to make the tabletop. Okay. Does it have to be a perfect circle? They show us a circle. No, it doesn't really. So this is just a straight up 2 different variables. So we're going to say 50 is the most you can spend. So whatever our variables are, they need to be less than, are you allowed to spend 50? This is always the hardest question of these. Are you allowed to spend $50? I would say yes. That really takes context. Our language is not perfect for that. English language isn't built to be perfectly mathematical. So it takes some intuition. But in this case, you can spend $50. And we're going to spend $60 times X, where X is the amount of aluminum, the glass, and we're going to spend an additional $1.75 per Y, where Y is the amount of aluminum. And we should write that. Let X be the amount of glass bought. Units in meters squared. And let Y be the amount of aluminum bought. And units in per foot. Good. I think that's going to work out. Find all possible combinations of the materials, and that's pretty much it. I'm trying to think if we have to go any further for that. You can choose the dimensions, find all possible combinations. So any X and Y that actually fill in this. What would this look like graphically? That would be the additional thing we'd want to see. So you would want to rearrange for the Y in that case. So we'd say $1.75Y. 50 stays on the opposite side, and the 60 is going to move across by subtracting it. And so far this sign didn't change, which is facing away from the Y. That was weird. You probably want to do that in 2 steps, but if you can see that, that's good. Basically, I flipped the whole thing and then subtracted the, the greater than, sorry, this should be facing the 50. I did that backwards. Yeah, flipped the whole thing and then just subtracted 60x. And then we divide by 1.7y. And I would need a calculator for that. Do I have one here? I get 34 point, well, let's just do 1 decimal, 34.3, negative 34.3 x and 50 is 28.6. So we could get a graph something like that, and then we would graph it. And roughly what does that look like? Well, it starts up high at 28, and it's going to be going down quite steeply. It's going to look something like that, roughly. It will be a solid line, and then we're looking for everything less than that. Now you can probably guess that since x and y can't be less than 0, it's actually only this little triangle that are real solutions. It's actually only this part that we care about for this solution. And we could even get very specific here. We could say our y values must be between 0 and 28.6. And our x values must be between, well, 0 and whatever this point is right down here. I don't know what that point is. I would have to solve it. Yeah, I don't have the solution here. So how would we find the x-intercept of this one? Well, we would set y equal to 0. So subtract that and divide by 34. So 28.6 divided by 34.3 is 0.83, roughly. And that makes sense because glass is way more expensive. You can't even buy 1 unit of glass because 1 unit of glass already is going to be $60. So you can only get 0.83 meters squared of glass if you're going to buy no aluminum at all. But aluminum, you could buy 28.6 feet of it. So we can find solutions and everything, or the range of solutions. Lots of things to do with it. Okay, lots of practice. You can do a bunch with technology. You should try some without technology. See if you can do them algebraically. This isn't too bad. Basically, it's just remembering how to graph and understand lines, remembering how to interpret all the different symbols, and remembering that one really, really big rule. Flip the sign when you multiply or divide by a negative. That's our one big rule. That's the only time you actually flip the sign. The rest of the time you can treat it like an equal sign and nothing actually bothers it. This is our only exception to treating it like an equal sign. It doesn't like dealing with negatives. Okay, give the practice some tries.